Okay, hi. I wanted to go over the answers to numbers 1 to 4 out of section 7.1 because I had a few questions on it and a few people saying that they struggled with it. So I want to go over that and kind of hopefully answer any questions that you have. If I miss anything along the way, if there's anything that I'm not explaining, please just ask me. So in number 1, they give us this triangle and they want us to prove that this angle is equal to this one. I put little funny check marks in there because that's what I'm trying to prove. That's what I want to keep in mind. That's what I'm trying to prove. So they first say, they put a blank here in the statement and it says definition of a midpoint. And what I would say to that is that BD is equal to DC. They told me that already, so I probably could have put given because they told me that. But they used the reason definition of a midpoint because this is a perpendicular bisector, which means it is in the middle. Angle BDA is equal to angle CDA. Now up here they say prove angle B is equal to angle C. So one of the questions that I had was how come or why do sometimes they only use one letter to reference an angle and sometimes they use 3. You're always better to default to 3, but the reason why they only used 1 here but they used 3 to describe it here was for angle B, there's only one choice. But if you said angle D, do you mean this side or do you mean this side? You have to be more specific about it. So it's angle BDA, so it's this one on this side, is equal to angle CDA, which is this one on this side. Now, I don't know what they have in the back of the book. I'm actually going to go there just so that I'm consistent with them. So in the back of the book, they have what I was going to put. They've told us that this is perpendicular. They've put the little square there. So this would be definition of perpendicular. Okay, because that's what that means. These two angles are equal because if they tell you that this is perpendicular, that's 90 degrees, then that would have to be 90 degrees on the other side. Then they say AD is equal to AD. Well, AD is part of this triangle on this side. It's also part of this triangle on this side. So that would be the reflexive property. The reflexive property is always when a line is shared between two different shapes. So now they say angle ABD is congruent to triangle ACD. Well, how do I know? Well, they did a side, an angle, and a side. So the reason, SAS. So if those two triangles are congruent, then those two angles, angle B, has to be equal to angle C. Now I could label it angle ABD or even angle ABC if I wanted to, but because there's only one angle at B, that's why they don't bother to put the 3 different letters. So that's number 1. I didn't get as many questions on number 1. It was actually the ones after that where I started getting some questions, but I thought I would go over that one. Hopefully just to answer some little things maybe that might have popped up there. So we're going to leave the statement and the reasons over on this side. And we're going to look at number 2. Number 2 has a triangle, and then it has a little triangle within that bigger triangle. And they say that this is equal to this. And they say that this angle in here is the same as this angle in here. They call this A, B, C, and D. See, now I couldn't just say angle B anymore because do I mean this, do I mean this, or do I mean that whole thing? I will have to be more specific. Now, what do they want us to prove? They want us to prove that AB is equal to AC. So they want us to prove that AB is equal to AC. Again, I'm never going to just say that and leave this all blank. We're going to do, they have a statement, BD is equal to CD. You have to come up with a reason. Then they say isosceles triangle theorem, and based off that, you have to give what the statement that would go with that reason would be. Then they say angle ABD is equal to angle ACD. And again, they want a reason for that. And then they make a really long statement. Angle ABD plus angle DBC is equal to angle ACD plus angle DCB. And again, they want a reason why you can say that. And then angle ABC is equal to angle ACB. And they even tell you why. They say substitution property, and we'll talk about that a little bit when we get there. And then they say angle AB is equal to angle AC, and they want you to give the reason. So, again, I'm going to flip back just so that I'm wording it the same way that they would. So, for this one, first, they say, first we have a dog barking. We'll wait till she stops. Okay, I think maybe, no, I thought she was done. She's not done. There we go. All right, and so BD is equal to CD. So BD is equal to CD. That's my favorite reason. They told me that. They're the ones who put the two little ticks there. They told me that, so that is given. Now they say, we're going to make a statement based on the isosceles triangle theorem. Well, based on the isosceles triangle theorem, if these two angles are the same, so let me just pull that little triangle out of there. If these two sides are the same, then this angle and this angle would be the same. In other words, this one and this one would have to be the same, because the isosceles triangle theorem says if two opposite sides are equal, then the opposite angles are also equal. So again, I can't just say that that's angle B, it's actually DBC. So angle DBC is equal to, this would be DCB, angle DCB. And that's the isosceles triangle theorem. Then they say angle ABD is equal to angle ACD. So this angle is equal to this angle. Again, my favorite reason, because they told me so. They're the one who put the little X's in there. I didn't do it, they did. So that is given. Then they said, if I take this angle and I add it to this angle, it's equal to this angle added to this angle. Now, I would call that the addition property, so do they, that's good. This is called the addition property. Basically meaning, if I add two angles together and two other equal angles together, then they have to be equal, right? If this is 50 and this is 40, and this is 50 and this is 40, if I add these two together, they have to be the same as these two added together because the angles are the same, duh. That's what I want to put in for a reason half the time, duh. But addition property is the proper thing, duh is not. By the way, neither is look at it. I tried that in high school myself. When they said prove this is congruent, this triangle is congruent to this, I went look at it. Yeah, it didn't go over well. Okay, so then they say angle ABC is equal to angle ACB. And they call that the substitution property. Basically, because I substituted all of this to be angle ABC, rather than saying this plus this, I said that whole thing. I substituted this for this, and then I substituted this for this. That's why it's called the substitution property. I substituted a new name for these two things. Bell, stop. Then they say angle AB is equal to side AB is equal to side AC. Well, if I know this is equal and I know that this is equal, so I know that these two sides of these two angles are the same, this again is the isosceles triangle theorem, because the isosceles triangle theorem says if two opposite sides are equal, then the opposite angles are equal. But you can reverse that. You can do what is called oh shoot, I can't remember the name. Anyway, but you can do the reverse of that. The word will come to me. Then if the two opposite angles are equal, then the opposite sides are also equal. So that would be the isosceles triangle theorem. I'm trying to remember some of the questions that people asked me. Danielle, I know you asked me 4 different questions. I'm trying to remember them and cover them. If I miss any, please let me know. All right, so that was number 2. Number 3. Number 3. Now I have to flip back again. 389. I think I'd be smart and put a bookmark or something in. Let me try that. 389. Just fast forward through me flipping through pages. How boring. Seriously. I think somebody dropped this book in a bathtub at one point or something. All right, number 3. So we have something sort of like that. It's not really like that, but you get the idea. They put a little thing here and a little thing here. When it looks like those little arrows on a line, that doesn't mean that they are equal. If they were equal lengths, they would have like ticks on them, like the little line going through them. When they have a line like this, when they have like a little arrow and a little arrow, it actually means those lines are parallel, not that they're the same length. All right, what does mean they're the same length is this one and this one. Those two are the same length because they have the what I call ticks on it. And then they label, this is T, this is P and Q and S and R. All right, well, here comes a dog, loudly. Hello. All right, so at number 3, hi, Wicket. Hi, Gabs. Gabs, you want to say hi? Gabs, you want to say hi? Come here, Gabs. Gabs came to say hello. Say hi, Gabby. Say hi. All right, Wicket wants her. I'm going to put her down. There we go. All right. So in this one, they want us to prove that TP is equal to TR. So they want us to prove, I'll just put a little circle, that this is equal to this. That's what they want us to prove, all right? And so they say, first off, QT is equal to ST, and they want a reason. And then they give this, and they say opposite angle theorem. I'm too lazy to write out all the words. And then they say angle P is equal to angle R. Again, the reason why they only use 1 letter versus 3, at angle P, there's only one option. And they leave a blank, and then they leave a blank, and they say angle, angle, side. I think I know what goes there. And then TP is equal to TR, which is what we want to prove, but they want to know why. Why can we say that? All right, so first, QT, oh my goodness, QT is equal to ST, my favorite reason, given, because they said so. Now they say opposite angle theorem. Opposite angle theorem is what I call a bow tie situation. If I have, wow, that was badly done, sorry. If I have two triangles that are hooked together, the opposite angles, see, to me that looks like a bow tie, that's why I call it bow tie. The opposite angles have to be equal. Now here's a place where I can't just say angle T is equal to angle T, because what angles do I mean? I want to specifically say this angle and that triangle and that angle and that triangle. So I'm going to say PTQ is equal to RTS. All right, and that's opposite angle theorem. Then they say angle P is equal to angle R. Well, this is that transversal parallel line thing, because they say these are parallel lines. So just imagine if those kept going. And these two are parallel lines. This is a transversal. This is a line going through it. So the Z rule says that alternate angles are equal. But you can't put Z rule because that's not like an official theorem. That is one teacher's shortcut for it. It is called the transversal parallel line theorem. That's my shorthand for it. Transversal parallel line theorem. All right. Now, we proved an angle, and a side. So we can now say that triangle PQT is congruent to triangle RST. And so that means that TP is equal to TRY. Well, because we just proved that we have congruent triangles. All right. I didn't actually look. I'm hoping yep, I did. Okay. I was hoping I had the same answers they did, and I did. All right. So that was number 3. Number 4. Number 4 says, wow, my stomach's going crazy. Hope you can't hear that over the video. Number 4, oh, that's lovely. Gives us a circle. This ought to be good. Gives us a center and gives us this, and it says those are right angles. And another one, and here, and it says that that's right angle. Puts a little line here. Hey, that is not half bad for me. And they say A, B, and C, and that little O just means that's the center of the circle. Now, they want us to prove that AC is equal to BC. So they want us to prove that this and this are the same. That's what they want us to do. And so they say over here, they make a statement, OAC is equal to OBC, which is also equal to 90 degrees, and the reason. And then they give us a blank, and they say the reason I can say whatever it is I'm going to say is because of the reflexive property. And then they say OA is equal to OB, and they want to know why. And then they say triangle AOC is congruent to triangle BOC, and they want to know why can I say that. And then they say AC is equal to BC, and they want to know why can I say that. All right, so let's start with the first one because that makes sense. Let's start with the first one, which says angle OAC is equal to angle OBC, and they are both 90 degrees. The reason, my favorite, they told me so, given. Then they give one which is the reflexive property. Well, the reflexive property always talks about shared sides. And that would be OC is equal to OC. Those two lines are shared. Where'd you come from, Rolly? And then they say OA is equal to OB. This one you might have had a hard time getting. OA is equal to OB. You might have had a hard time getting that one. But here's what I want you to look at. This is a circle. This is the center of the circle. This line is going to the edge, which means it's a radius. This is the center. This line is also going out to the edge, so it's also a radius. By definition of a radius, it doesn't matter. As long as you start from the center and go to the edge, it's got to be the same length no matter where you draw it in the circle. So they say radii of a circle, meaning they're both a radius of the circle. Radii is the plural of radius. Welcome to English class. But you could also word it this way. You could put definition of radius. Or they just put radii of a circle. I would accept either one. They're both a radius. So they are both radii of a circle. And so that's why. Then they say angle OAC is congruent to triangle BOC. Well, what did I prove? I proved that this is a 90-degree angle, meaning those are both right angle triangles. I proved this side is equal to this side, and I proved that the hypotenuse in each one are equal. Back a few pages, there was what was called the hypotenuse side congruency theorem. I believe it was example 5 out of the last thing we did. It was somewhere back there, which basically says if you can prove that one side and the hypotenuse of a right angle triangle are the same as one side and the hypotenuse of another triangle, then you can say that those two triangles are congruent. So that's what they say, hypotenuse side theorem. Some of you may have put side angle, but that's not really a reason. The angle would have to be in between the two sides that you proved, and it's not. So it's hypotenuse side theorem. And then AC is equal to BC. Why? Well, because we have congruent triangles. I hope this answered the questions that you had. I know a couple of questions that were asked, I actually wasn't particularly clear on what it was you were asking. So I hope by doing this, I've actually answered whatever those questions were. If I didn't, please ask them again, and I will try and get into your brain and figure out what it is you're saying. Or perhaps we can do a video meeting on that. I am thinking about throwing around the idea of maybe just once a week having a short video meeting over Zoom. It doesn't have to be a full period long or anything, but just to kind of, hey, let's check in with one another and see how it's going. So I may do that about once a week. Again, I'm spending a lot of time trying to figure out the best way to do all this. So it's a work in progress, guys. I'm learning as I'm going. You're learning as you're going. It's the best that we can do. You guys are doing a great job. Keep it up. I know this is not the easiest of circumstances. So we'll get there together, all right? So we'll talk to you later. Bye. Stop barking.